Point 4, we're looking at the vector and parametric. So we know those words, vector and parametric. It's the same two words there, but it's equation of a plane. So this is new, of a plane. What we've done so far is we've done equations of a line, and now it's equation of a plane. So when we describe a plane, we're trying to describe a surface, right? So we're trying to describe a surface. So if I was trying to describe, say, this Post-it note, we're trying to describe this surface. It could be floating here, this surface here, like that. In order to describe a plane, I need, so vector equation of a plane, I need, you'll see here, SA plus TB, where A and B are two non-collinear vectors. They can't be the same vector. I want A and B to be two non-collinear vectors. What that means is that I need two vectors to give me the surface of this. So if I had, say, a purple and a blue, if I have two vectors that are non-collinear, I can describe this as a plane. So in other words, they can hold this Post-it note, right? So it could be to the side, it would be like this, but those two would give me the surface. So that's giving me the surface, that gives me the plane surface, these two. If it was one vector or two collinear, that doesn't make sense because look, it can twist around, it's going to fall. There's no way to describe it. So I need two vectors to describe the plane, so this surface here, right? So two vectors, and that describes the plane. So that's what this is. So A and B are two direction vectors. So not one direction vector, I need two. One is not enough for a plane because look, in 3 dimensions, you can't give a single one. So I need two to describe the plane. So if I have two direction vectors that are not collinear, I can describe this plane here, the surface that holds this plane. Okay.
What if you were to add like one and then two coming like down and up?
Sorry, if I had one and then the second one was down?
Yeah, sort of like that.
Yeah, but that's it. So, and this is still would be a plane this way, right? So I'm not saying it's horizontal, it's just because I was showing it on the camera.
Not perfectly.
But every vector can be extended, right? So every vector can be extended. So the question is, what if it's like, so what if it's like over here, right? So then I would extend it until they crossed, and then that's your plane, right? So you always have, and remember, when we're writing our vectors in algebraic form, they're position vectors, which means they are always starting at the origin and heading out. Right? So every vector written in algebraic form automatically is starting at the origin and heading out. So two vectors would describe the plane that or the surface that the plane would be on. Right? So I need two vectors. Right? So two vectors, and those will give me our two direction vectors. Okay, so I need two. So that's what the A and the B are. R naught is still a point. So that is still, R represents the position vector of some particular point. So it's the vector form of any point. All right. Then, does that make sense? We've got here, and we've got, the only thing kind of changing here is that we need two position vectors, or two direction vectors. Here, parametric, that's vector. So vector. Parametric of a plane, and this is of a plane, will have the same form as the other parametric, which means that we're going to take the x. So I'm going to take the x with the x naught and the SATB. And then the y with the y naught SA2 and the TB2. And the z with the z and the z. Okay, so that's all this is saying. And then now you have to write both s and t are elements of real. So you have to have both. Right? And s and t are usually the variables we use as our coefficients when we have our direction vectors. Okay? They're just typically used when we're doing parametric and vector form. S and t are kind of their favorite. All right, let's jump right into making an equation. Oh, and there's no symmetric. So symmetric means that I solve for the t and set them equal. Here, it doesn't make sense. It's not useful. If I solve for t, I have another variable there anyway, s. So it's kind of like, well, why would I do that? It's not useful. The reason why they created a symmetric form of the line in 3 spaces because it was useful. Like you set them equal to each other. We can use that for a bunch of checks and proofs and stuff like that. But here, solving it for t or s is not useful because then you have another variable anyway, so it's not going to help anything. So they went, meh, there's no point. Okay, so far we have a vector and a parametric form of a plane, right? So we've got 2. We're going to do another one in 8.5, so hang on. But 2 here in 8.4. First example, determine the vector equation and corresponding parametric equation for the plane that contains these 3 points. So again, so I need a plane that has 2 vectors. I drew it in 2 space just so it's easier to see. I need 2 vectors, right? Here, I gave you 3 points. That's not 2 vectors. So what am I going to do? I'm going to create vectors out of those points. So you can create a vector AB to AC, BC to A, like there's many combinations, right? I usually just take one and do AB, AC, or BA, BC, right? So I usually just do one, just so I know. You cannot use AB and BA because they're the same vector, right? Collinear, same vector, so that would not be useful. So I would have to go from AB to AC or BC to BA. You want to include all 3 points. Otherwise, you're going to get, you should look at it and go, oh, wait, that's the same vector. What did I do? I used the same 2 points backwards and forwards. Okay, so we're using all 3 points. So for A here, we need to create, so make M1 and M2. That's my thought process. And it will vary, right? Because it depends on which 2 you use.
So how do you know A and B are parallel?
How do I know A and B? I didn't say A and B are parallel. I said AB and BA would be parallel.
Oh,
yes.
sorry.
So A to B and BA would be parallel. Yes. Yeah. Okay. So then let's create 2 direction vectors. Again, it's going to vary. I usually just start with one and I go AB, A, and then AC. Right. So again, you don't have to get fancy. Just make sure you use both. So for M1, and I'm going to tell you I'm using AB, but you don't have to tell me. Right. So you could just go ahead and use it. So AB. Right. I'm creating the vector AB. And here, so A to B would be -1 minus minus 1, so 0. 1 minus 3, so -2. And 0 minus 8, so -8. And again, we like to always reduce this, please. All right, why have it not reduced? So be divided by -2, so 0, 1, 4. Okay, so we do want it reduced. And then we're going to create an M2. So M2. And I usually do AB, AC, right? Just don't be fancy, don't do anything silly. So AB, AC. And here I would do 4 minus 1 is 1, so 5. 1 minus 3, so -2. And 1 minus 8, so -7. Okay, can't really reduce that one, so I'll leave it that way. I like to start with the positive, so I usually leave it that way. So we're good to go. So we've got our 2. And our vector equation, so we're doing both a vector equation and the parametric equation. So vector equation would be, and you can put R equals or XYZ equals, right? So it's up to you. So this will be vector equation and parametric. Yeah, so I'm just going to state which is which. So I'm going to go X, Y, Z. And remember, you can put R equals or X, Y, Z equals. And I'm going to grab a point. So any one of the 3 points will work. Either A, B, or C, doesn't matter. So again, marking this is not super fun. So I know that that could be A. And I'm just going to say or B or C. Right, so any one of those points goes there, and then plus, and again, as per usual, we have to put the T, right, T times, and then we have 2 direction vectors this time. So 0, 1, 4, or ST. Oh, shoot. Usually they do it alpha, so I'll stick to our usual. So ST, so we usually do S as 1, and then plus and T. Okay, it's not wrong if you do it the other way, but typically we do alpha order, right? So they'll be here, and then we go 5, -2, -7. And because I mentioned the parameters, I have to do ST are both elements are real. Okay, so please don't forget this. This is a pain, I know, but you have to write it every time. Okay, so that is my vector equation, and I asked you for A. I also asked you for parametric. So switch that to parametric. So parametric would be x equals -1, no s because it's gone, and then plus 5t.
No, that's because it's a 0.
0, yes. No s because it's a 0. Y equals, and it's going to be 3s and minus 2t. Okay, and again, I shouldn't have to say this, but don't go between lowercase and uppercase, right? S and T are lowercase, so we've got S and T, which is usually what we use. We don't usually go uppercase, lowercase. Okay, same with the X, Y, Zs. Here, next one, Z is 8 and 4S and minus 7T. And yes, because I have an S and T in my parametric, you do have to put S, T are elements of real. Okay, so yes, that's stated each time we're mentioning S and T. Okay, so that's for A. Determine the vector and parametric equation for that. We've got that plane, all done. For B, same question we've asked you a bunch of times. Does this point lie on this plane this time? So does it lie on the plane? And we're going to do the same sort of process. And our process for this is going to be, our process here is we're going to substitute P. So I'll do P 1413 as the X, Y, and Z into the parametric. Okay, into your parametric form. I'm just going to write what I'm thinking. So I'm subbing this point into my parametric form. And then I, again, thinking about this, when I sub this in for X, Y, and Z, how many variables will I have left? 2. If you have 2 variables, S and T, how many equations do I need to solve for 2 variables? 2 equations. 2 equations, 2 unknowns. Okay, if there's 2 equations, you need 2, if there's 2 unknowns, you need 2 equations. 3 unknowns, 3 equations. Okay, so you need 2. I have 3. So what we're going to do is what we did before, use 2 to solve. So use 2 equations to solve. Check in third equation, right? So this is my thought process, is that I'm going to take this, you don't have to write this, but just for your thoughts, I'm going to take this, sub it in for X, Y, and Z into the parametric. We're going to use 2 equations to solve it and check it in the third. So you save the third one as untainted, untouched, and you check to see if it works in the third. If not, what can happen is that it fits to 2 of them, but it's off kilter and it's not actually sitting on the plane. Okay, so that's why. So you use 2. Sorry, question?
Well, I mean, in this case, we can just solve for T because we only have 1, but then we still put it.
But you're still checking in the third, yeah. So no matter what, yeah, so you're checking in the third. Right. Okay, so I have my equations. We're going to sub in, so I'm going to number them just 1. We have X equal -1 plus 5t. Whoops, sorry, 5t. And we would substitute in 14 here. Then in equation 2, this is going to be y equals 3 plus s minus 2t. Make sure you can read your own s versus 5. Sometimes I get students who think that their own writing is 5 and then they go wrong from there. Okay, it's hard, I know. Y is 1, right? So you sub that in and you're going to solve this. And then for third equation, we have z. I'm just writing them so I have them written, plus 4s minus 7t, and you would sub in 3. So 8 plus 4s minus 7t. Again, it doesn't matter which 2 you use to solve. You save one of them untainted for the check. Okay, so make sure it's not used at all. So usually I just separate it and I say this is my check. So, okay. Again, make sure your answers are clear and organized. There's a lot of little calculations all the way through this, so I'm going to just note that down. So I want clear and organized answers. Okay, there's so many little calculations in this chapter, I should not have to figure out what you're doing. So clear, organized solutions. Okay, it has to be something I can just read and understand what's happening. Otherwise, you can see just lots of little calculations everywhere. I don't know what's going on. So see how I'm titling it? I got 1, 2, subbed it in. I'm saving this one for my check. Okay, so I look at it right away. I go, okay, you solved it. You checked it here. We're good. Okay, I shouldn't have to figure out what you're doing, right? The calculations are easy. It's just you're now at a point where I need you to be able to organize your answers. Actually, I always expected this, but okay, so 15 equals 5t, 3 equals t. Here, we can take that and we can use these two, and I'm just going to sub it right in, right? So it's, again, one of the ones where I have the t, so you can sub it in to find your s. Otherwise, you would do a system of equations, elimination, or substitution, right? Up to you, but this one was easy enough to solve. We're going to take this one, and we're going to get 1 equals 3 plus s minus 2 times 3. Here, 1 equals 3 minus 6, so s minus 3, 4 equals s. Okay, so any way you want to do it, you can do it by substitution, elimination. This one was easy enough for me to solve. So then you take both of these guys now. So you're going to say, okay, I've got this one, and you're going to check. Okay, and you don't have to write this, but just for your brain to say, what did I do? I took both of those answers, and we're checking it over here. And then I'm going to check. So we're checking here. We're checking that s equals 4 and t equals 3. And we're going to get 3 equals, and I'll let you put it right into the whole thing. So 8 plus 4 times 4 minus 7 times 3. Does 3 equal 8 plus 16 minus 21? Plus 16 minus 21, that is 3, right? So 3 equals 3, so we're good to go. If it doesn't equal 3, you would take your pencil and put a slash through it, say, no, 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 this is where the mistake happens. You're saying this does not equal, and then do your conclusion. So you'd say left side equals right side, therefore, yes, P does lie on the plane. Okay, if it doesn't, then you would say, nope, it doesn't, because the left side does not equal right side, and then conclusion.